In this video, we will talk about how to find a basic feasible solution, or BFS, to the balanced transportation problem using Vogel's method. There are 4 steps. In step 0, we do some preparation for the following 3 steps. For each row or column, we calculate a penalty by subtracting the smallest unit cost in the row or column from the second smallest unit cost in the same row or column. In step 1, we find the row or column with the largest penalty, and then find the cell with the smallest unit cost in the row or column. Ties are broken arbitrarily, which means if there are 2 or more rows or columns have the same largest penalty, randomly select one of them. Then allocate as much as possible to the selected cell and adjust the associated amount of supply and demand by subtracting the allocated amount. In step 2, we cross out the row or column with 0 supply or demand. If both a row or column have a 0, arbitrarily cross out one only. In step 3, if exactly one cell is left uncrossed, cross out the cell and stop. Otherwise, we need to go back to step 0 and repeat the process. For example, this is the transportation tableau. The unit transportation cost is shown in the top right corner of each cell, like 6, 7, 8, and so on. The total supply for the first row is 10. For the second row is 15. The total demand for the first column is 15. For the second column is 5. And for the third column is 5 as well. Now in step 0, we need to calculate a penalty for each row and each column. For the first row, the smallest cost is 6, and the second smallest is 7. 7 minus 6 is equal to 1. For the second row, the smallest cost is 15. The second smallest is 78. 78 minus 15 is equal to 63. For the first column, the smallest cost is 6, and the second smallest is 15. 15 minus 6 is equal to 9. For the second column, the smallest cost is 7, and the second smallest is 80. 80 minus 7 is equal to 73. For the third column, the smallest cost is 8, and the second smallest is 78. 78 minus 8 is equal to 70. Thus, in step 1, we need to find the row or column with the largest penalty, which is the second column with a penalty of 73. Then we need to find the cell with the smallest unit cost in this column, which is the top cell with the cost of 7. We need to allocate as much as possible to this cell and subtract the allocated amount from supply S1 and demand D2. The largest amount we can allocate is 5, because if we allocate more than 5, D2 will be changed to a negative number. We put 5 here and subtract it from D2 and S1. D2 will be 0 and S1 will be 5. This is the new tableau. In step 2, we cross out the row or column with 0 supply or demand. In this case, only D2 is 0. We will cross out the second column and remove D2 and the penalty from this column. Now we need to check step 3. Do we have only one cell left? No, we have 4 cells left. We need to go to step 0 and repeat the entire process. We need to update the penalty for each row. For the first row, the smallest cost is 6. The second smallest cost is 8. 8 minus 6 is equal to 2. For the second row, the smallest cost is still 15, and the second smallest is still 78. So the penalty is still 63. Now we need to find the row or column with the largest penalty, which is the third column with a penalty of 70. Then we need to find the cell with the smallest unit cost in this column, which is the top cell with the cost of 8. The largest amount we can allocate to this cell is 5. We put 5 here and subtract it from S1 and D3. S1 will be 0, D3 will be 0. This is a new tableau. We cross out the row or column with 0 supply or demand. In this case, D3 and S1 are both 0. We randomly choose to cross out the last column and remove D3 and the penalty. Now we have 2 cells left and we'll repeat the process. We need to update the penalty for each row. We only have 1 cell in the first row and cannot calculate the penalty. Same thing for the second row. So we remove the penalties for these 2 rows. Now we need to find the row or column with the largest penalty, which is the first column with a penalty of 9. Then we need to find the cell with the smallest unit cost in this column, which is the top cell with a cost of 6. The largest amount we can allocate to this cell is 0. We put 0 here and subtract it from S1 and D1. S1 will still be 0, D1 will still be 15. We cross out the first row and remove S1 because S1 is equal to 0. Now we only have 1 cell left. We just allocate the remaining amount, 15, to this cell and cross out this row and this column. And remove S2, D1, and the penalty for the first column. This is the final tableau. Remember, this is just a basic feasible solution. It's not the final optimal solution to the balanced transportation problem yet. How do we interpret this basic feasible solution? It means x1, 1 is equal to 0, x1, 2 is equal to 5, and so on. All other xij in the blank cells are equal to 0. If you wonder if this really is a basic feasible solution, you can check whether it satisfies all the equality constraints. Let's bring back the original supply and demand. The sum of the first row, 0 plus 5 plus 5 is equal to 10. Sum of the second row, 15 is equal to 15. Sum of the first column, 0 plus 15 is equal to 15. Sum of the second column, 5 is equal to 5. Sum of the third column, 5 is equal to 5. So all the constraints are satisfied. This is indeed a basic feasible solution. The advantage of using Vogel's method is that it can avoid basic feasible solutions with high costs, and the generated basic feasible solution may be very close to the optimal solution. Thus, it does not need too many pivoting iterations later. The disadvantage is that it is more complex than the northwest corner method and the minimum cost method. Okay, that's how we find a basic feasible solution to the balanced transportation problem using Vogel's method. Thanks for watching.